So today's panel discussion is titled Innovations and Challenges in Automotive Painting, a review of the past and a look to the future. We're tying it into the 50 years of, of focus and what's been going on in the past 50 years in terms of innovation, responses to market needs, and then what's going to happen in the future. Regarding questions, ask any questions you want on the Hodapp, but also if you'd like to make some comments about, you guys forgot to talk about the importance of cathodic E-coat or something like that, put it in here or get up and help us with those discussions. Appreciate that. So let me introduce the panelists. We've got our pictures up on the wall there. So I'm going to start with Dr. Mark Nichols. Mark is the Senior Technical Leader for Materials and Coatings at Ford's Research and Advanced Engineering Organization. Mark has his degrees from University of Michigan and University of Illinois, and his PhD in particular from Michigan. Mark joined Ford in 1992 to work on durability of elastomers, but in 1994 he switched and joined the coatings applications group there. The coatings research group there. His particular topics of interest include coatings weatherability, novel paint processes, battery manufacturing, corrosion, and fracture behavior of coatings and films. Also, interest in his work includes color science and functional services, and maybe most important, Mark is the editor-in-chief of the Journal of Coatings Technology and Research. Our next panelist, Sarah Hodapp, is the Senior Manager of Paint Execution at General Motors. She has extensive experience in automotive paint operations, coatings materials, and manufacturing execution. Sarah joined GM after earning her chemical engineering degree at the University of Notre Dame. She joined GM in 1999, working in various quality, launch, and paint manufacturing positions at both the Moraine and the Hamtramck plants. In 2017, she moved to the Vehicle Systems paint to manage advanced product development. And in 2019, she moved to the role of paint materials manager, responsible for the development, launch, and continuous improvement of paint-related materials, and manage the annual color development program. In her current role, Sarah leads cross-functional teams responsible for delivering robust paint shop performance with a focus on quality, launch readiness, and operational stability. Dr. Jack Bergman has spent his entire 38-year career at PPG. Is that right?
Yes, sir.
Jack received his bachelor degree in chemical engineering from Virginia Tech and his PhD in chemical engineering from Carnegie Mellon University. At PPG, Jack's held a variety of positions. Currently, he's the Technical Director of Formulation Science for Corporate R&D. Previous roles include Director of R&D for Architectural Coatings in the U.S. and Canada, Associate Director for Automotive Coatings R&D at the Coatings Innovation Center in Allison Park, Technical Director for Substrate Protection Systems at the laboratory in Cleveland. Also, Technical Manager for Elastomeric Coatings and Product Manager for Automotive Clear Coat. Dr. Mike Koerner is originally from Philadelphia. He studied chemical engineering at Drexel and Princeton universities. He joined DuPont Performance Coatings, which is now called Axalta Coatings, 34 years ago, sorry. So he spent 5 years in Germany and then transitioned to the Waterborne Technology Development Team. He led a research group to develop technology for coatings with higher productivity, lower bake temperatures, and digital applications. After Mike retired as a fellow from Axalta, he moved to a process engineering role at Aero Aggregates, which is a small manufacturer of foamed glass aggregates. This gave him to join his wife on trips all over the country, helping the company. They both recently retired from those roles, and they plan to continue traveling all over the world. So before we get started, let's give this group a round of applause.
It should just be done now.
So here's how we've set this up. I mentioned kind of tying together the idea of what we've done in the past 50 years, what we're going to do in the next who knows how many years. So we've got, prior to 2025, what are the driving forces and what were the innovations that responded to those things. So we've got on this first slide the driving forces being appearance, environmental regulations, mostly VOC compliance, durability, acid rain and scratch resistance, and then as you're fixing those things, maybe you've developed other problems. So learn from your mistakes and what are the unintended consequences. Some of the innovations that were developed in this time period were cathodic eco technology. For those of you that are really particular, it officially commercialized in 1973, so we go 53 years back instead of just 50. The shift to base coat, clear coat in the 70s and 80s, multi-substrate and using plastic parts for lightweighting in the 70s and 80s, environmental regulation and VOC reduction really across the whole scope. That never goes away, does it? Compact processes and footprint reduction of the paint shop in the 2010s, and formulation component evolution. What in the world does that mean over the entire scope? What we mean by that evolution of formulation components is, back in the 70s, formulas were a lot simpler, and they got more complicated because you'd fix something by throwing something in, and then the next chemist comes along, and I'm not going to take anything out of it, but the next problem requires another additive. Also, the additives industry became much more helpful. So we might talk about what we're doing to formulations to meet those regulations and meet other things. Speaking of regulations, well, where do we get started? Unless one of you wants to jump in. But I thought, let's start with VOC regulations, because that never goes away. Back in I don't even remember what, we were like 30% solids back in the 60s and 70s. And then that need to get to lower VOC led to the development of base coat, clear coat, where you could control different aspects of that. So who would like to start just talking about that and maybe your experience with, we need to raise the solids, lower the VOC, whatever we need to do to get there. And if it includes the transition into water systems, what did that do? How did that lead to new innovations, et cetera?
Yeah, that's a lot. But let me just start off a little bit with solvent-borne and some of the basics. If you think about,
move your mic a little closer. Yeah,
if you think about coatings formulations from the 70s and 80s, we refer to those as medium solids after you already had enamel cross-linkers. But the move from medium to high solids substantially was a reduction in molecular weights. And that seems simple enough if you think about the average polymer. But if you think about it from a distribution of polymers that would come out of a free radical polymerization, there's a significant risk of non-functional or different functionalities on polymers. Jack, I'm sure you are aware of this as well from BBJ. I'm sure that the physics is the same at DuPont, Axalta, BASF, any paint supplier. So I think that there was a lot more attention to functional distribution on polymer chains as we made that change from medium to high solids. And maybe we can just talk a little bit about that before we go on to waterborne. Jack?
Yeah, certainly high solids now has been around for quite some time. And as Mike says, many challenges, and I think the industry has handled that well. Moving forward from there, waterborne coatings, especially on the base coat side and primer, has been around a long time now as well. Looking a little bit toward the future, as I think back, really haven't been a lot of changes in VOC regulations, even globally, in quite some time. And we're starting to see, I think, in other industries, in other markets, pressure on VOC again, which I think makes a lot of sense because of just the sustainability trends, across the world. So we don't have a lot of regulation that I'm aware of changing so much in the automotive industry, but I see at some point in the future, as formulators, Axalta and PPG, I think we're going to be asked to start lowering VOC again, and because we're seeing it in other industries.
I think one of the interesting things is that, we're all smart people in this room, and we all essentially are operating in the same regulatory environment, the same economic environment, yet companies have come to very different answers. If it was obvious that we should all be, for cost and quality and all those things, we should all be doing waterborne base coats, and then we would. But if you look at the market, it's actually quite a big mix of solvent-borne and waterborne, and some companies are more heavily in one area and some in other, in 2K some places. The fact that we didn't all converge to the same solution, I think, is interesting and tells you how difficult it is to really weigh not only the formulation but the process and your footprint to come to the right or the optimized solution for your company or your footprint. I just think it's interesting that we still have a wide variety of ways we solve the same problems.
Mm-hmm. Yeah, I guess I'll just add, I'm not sure if VOC related, but we've definitely seen changes in abatement requirements from both state and federal levels. And so when you look at that and the requirements for abatement, we are constantly having conversations on, our direction at GM has been waterborne 2K for some time, but maybe we need to revisit solvent-borne based on, the changing environmental regulations that's coming out. So again, it's multiple solution kind of industry out there, and you're looking at cost and for capital costs and both material costs and what long term, even tier one is solvent-borne, waterborne better for the suppliers as far as their carbon footprint, but maybe not on the other end. So it's kind of that holistic approach to the solution.
I think it's telling that just the other thing to add, clear coats are almost entirely solvent-borne. I mean, with very few exceptions globally. What does that really say about the challenge? And clear coats perform very well, but again, just think about the future. Is there going to be a point where we're just going to have to do something different for sustainability reasons?
Chinese government might have something to say about that, but
Usually
but
something
for sure.
triggers it in some region,
Yeah,
and
for sure.
eventually it finds its way across the world.
Yeah. So, migrating to one of the other comments that John brought up is around the transition to base coat, clear coat. I think that's another really good example and a great opportunity that we had at that transition to move functionality around a little bit so that we could let the base coat concentrate on color and color capability and metallic flake orientation, and let the clear coat take care of environmental etch and other kinds of more weather resistant kind of activity. So I think mixed into the VOC or regulatory drivers, there's been some real opportunities for paint and paint technology development to make systems better and stronger. I don't think any of us are looking forward to going back to monocoats anytime soon.
They have their place. But yes, in general, yeah.
We're using them a little bit. I don't recommend it.
Sarah, you brought up waterborne and solvent-borne base coats. Back in 2007, I'm going to refer back to John's talk this morning from the keynote, where he described the three big colors are black, white, and silver metallics. 2007 was the high point of silver metallics and really, really bright silvers that posed a real challenge for higher solid solvent-borne base coats, where microgels were used for rheology control. And then the waterborne base coats in the same color, much easier because solids were much lower, rheology was easier. Can any of you guys talk about how those challenges, I mean, like Ford had it difficult and easy at the same time because almost all your plants were solvent-borne. GM had some plants waterborne, some plants solvent-borne, but your customers expected the same color to come out of all those technologies. Can any of you talk about how you dealt with that, not just silver metallics, but keeping color consistency with all these different technologies that your plants are using?
Sure. In-house within DuPont Axalta, that's a constant discussion point. And to add a little more complexity to it, think about the same color for paint on plastics as what you have for body coats as well. So really you have 3 different platforms that need to arrive to the same color solution. And when you add metamerism and other concerns like that, it becomes a very complex issue and something that we deal with on a regular basis. But I think, you know, paint suppliers have been wrestling with this for a long time. So we have a toolbox of solutions, whether that's certain kinds of rheology control agents or different combinations of pigmentations that we would use. That's really something that I think paint suppliers are well practiced at this point.
Yeah, I mean, and the other added complexity is even if you're talking about the same technology, one plant might have a very different level of automation compared to another plant, but you're expected to hit the same color position in both plants because maybe they're actually producing the same plant. Maybe it's 2 different truck plants and they're the same vehicle, but one is one level of automation, and that can really make it difficult to hit some of those color positions, especially the high travel colors.
Yeah, and I can just add, as part of our color development program, we initially off the bat, when we get a color from design, we go and we have our suppliers spray it in a waterborne and a solvent-borne, and so that we can see, you know, where that color lands. And if we need to go back to design and say, hey, this is going to be slightly darker or slightly whatever, we get agreement on that prior to. So there is some work up ahead to make sure that the color is achievable across the technologies and across the equipment applications.
Do you have something?
Well, I would just say, just adding to that, I think part of the growth of waterborne over the years is really provides the opportunity to go to lower solids, you know, without raising VOC to get the travel for those highest glamour colors.
Very good. In that line of discussion, somebody mentioned plastics. And, you know, when you think about multi-substrates and plastics, TPO bumpers came on and they were dominant. But the Ford Taurus decided not to use that. They used the Xenoid bumper, which was a polymeric blend, and the adhesion qualities, et cetera, much different than, like I was trying to make paint for plastic parts, and you put it on TPO, everything's great. You put it on that Xenoid bumper and it starts peeling off after 2 or 3 years. Which brings to mind, you know, that connection between the designers that are saying we need the Xenoid for the wraparound properties that the TPO can't give us, but, you know, how does the paint guy understand how his paint that works on plastic maybe doesn't work on all plastics? Did you guys have some issues with that in all that beginning of use of different types of plastics?
Yeah, so thanks for bringing up that memory. For sure. Looking back, and this, we could use TPO versus rim or Xenoid bumpers as one example, but if you look back at the history of when we've made big paradigm changes in automotive painting, so I think about going from monocoat to base coat, or from 3 wet processes, compact processes. It turns out there were always failure modes that we didn't really know about until we did it, right? Mm-hmm. And it wasn't because we weren't trying. When I say we, I mean the whole industry, suppliers, automotive companies. It's not that we weren't trying, it's just that the chemistry and the physics changed, and it's hard to understand what you're missing if you don't really know about it. And so if you look at what our paint, John McElroy mentioned this morning, he said, we should throw away all the specifications. And that made most of us in the room probably gasp, at least those of us who've been around for a while. And, you know, a lot of those specifications are there for a reason. And a lot of the reason they're there is we learned a hard lesson somewhere. And sure, are we over-specified in some areas because things have changed? Sure. But if you look at Xenoid bumpers, or you look at the transition to base coat, clear coat, mistakes were made, and we've learned from them, and we've gotten better. But but you know, you still, if you think about the next, whatever the next paradigm shift will be, we'll probably make some mistakes. And,
Yeah.
you know, it's hard. Making cars is hard.
So I think for, you know, a couple of old timers like us, then we remember some of those tragedies and we remember the origin stories
Yeah.
for those specifications. But if you kind of look out in the audience here
Yep.
today and you look at new formulators coming in, you know, 20, 30 years old,
Yep.
there should be a serious concern for how do we pass on that institutional knowledge or that industry-wide knowledge
Yeah.
to the next generation of formulators. And I think that especially young formulators need to be very conscientious about recognizing from where those specifications come.
Absolutely.
Because it's a little bit more than just an accumulation of all our past sins.
Yeah, for sure. Yeah.
Yeah, and I think we've been doing the, you know, the deep dive into specifications. You know, this morning's presentation kind of highlighted the need, and also a quicker turnaround at a customer that wants colors quicker. So it's looking at that and trying not to peanut butter those specifications. You know, the last 20, 30 years, we've gained a lot of knowledge about what colors are high risk and what colors are low risk, and do we need to necessarily do the same testing on every color? We know we have high risk colors, and that's probably where we need to spend the most focus and the most time, and maybe we can turn some of our lower risk spaces over sooner. So,
You know, and I think, you know, for people new to the industry, you know, specifications and testing, you know, can provide a requirement or to pass through to commercialization. But I think the real key is to understand the fundamentals behind the specification. So we'll test adhesion, but, you know, the fundamental for delamination is really light transmission through the base coats. And you know, some specs may capture that well enough, some may not. That's why there's color dependence. But just to recognize if you don't have hiding really even into some of the visible light on your base coats, you're going to have risk to delamination, which we don't see so much.
We do not.
But we saw a lot throughout our careers.
Yep.
So, you know, it's a lesson that I think we have to be sure is passed down.
Yeah.
Just one example, really.
Yeah. I think one of the other things we've learned is how much of a factor application is with respect to material performance, right? So if you had gone back, I started, 30, 40 years ago, most of the specifications were written around, we're going to apply the target film at the target bake and we're going to test that performance. And I think we've learned that we have to really explore both bake windows and film build windows to really understand a lot of the properties, especially the long-term performance properties. We'd like to think we're painting every vehicle perfectly, but we don't. Robots go down, you go into degrade mode, you're not going to have quite the film build coverage you were, or uniformity. So all these things can happen. So what you're doing on the process side deeply affects what's going on the performance side. And I think that's been something that's really matured in the last 20, 30 years as we've changed some of the technology.
Yeah, I'm glad you brought that up. So I wanted to kind of go a little bit into 3-wet technology or consolidated process, because I think that kind of picks up on what Mark just brought up, and that's that as a formulator, you're trying to ask a base coat to do the function of a primer, and that puts an onus back on the process and how much process control the application and the film build control and everything else is. And so as I see us pushing for, great achievements in productivity, is that you actually get a narrower process window that you have to fit in to make those things work.
Yeah, agreed.
How much, how much interaction is there between the paint formulator and the applications engineer? We were just talking about compact process. I would imagine a lot of that is trial and error, but is there a lot of communication? Is that an area of improvement for the industry?
I would say maybe I won't go back to the formulator, but certainly we're, I think, improving in terms of cooperation between the application hardware suppliers and the paint companies getting together, because it really is a marriage of the hardware and the application technology and the formulation
Yeah.
that can provide whatever it is you're looking for, higher TE or better appearance or whatever. But you can't silo the formulation development and the application development.
Right.
They kind of need to occur at the same time.
Yeah.
Yeah, it's a hand in hand, right? Again, it's all that upfront work, recognizing where the color possibly could go and what we have, GM, I don't think builds the same paint shop twice, so we have a lot of different technology across our shops, so we have to make sure that color can fit everywhere, and so we do look at that. We'll spray it with different bell types.
Yeah.
And for sure.
And that's done in the lab before you're
Yes,
taking it to the
all of
plant.
BASF and Axalta have, can probably complain on how many panels we make them run to before we give the okay on a color, so.
Yeah, very good.
And when, I think, critical groundbreaking technology formulations-wise come out, we'll get together with Fanuc or Door or one of the applicator companies to try to work through what sort of process and application needs are necessary, sometimes before we bring it to the OEM customers.
Interesting. Mike, you brought up for the younger formulator, and I brought up earlier that generally I don't reinvent a paint formulation. I go grab something that's already being used and I modify it to the application. But I generally am afraid to remove something because unless I really understand what it's there for. I think this morning John McElroy, I don't know if he was talking about paint formulations, but he was talking about, he did mention things that are put into a system that are, when he was talking about the electric cars, that they don't, the engine mounts didn't need to be there anymore because it was just supporting a battery. If I take that to the idea of paint formulation, what would you guys advise younger chemists how to approach that, how to understand whether I can remove something, adjust it to fit the particular application?
Well, I think it all, really comes back to the testing. And, one thing to me, one of the rules of formulation, if you have a good formulator, you can assign them to a product and say, make it better. And I pretty much guarantee they're going to make a product better. And, we commercialize after a body of work, we might pass a spec, and it's like, we've got to paint cars, we've got to commercialize. But again, a good formulator will come back and say, well, I had 5 more experiments to do, I can still make it better, and I think that's true. And it's the same thing with, the point I think we know, tend to add, not take out. But if you decide that there's a project, let's simplify this formula, you'll undoubtedly make it better. If that's where you decide to focus.
Yeah, the
your work.
other instruction you'll get is, okay, we like this, now make it cheaper.
Yeah.
Yes.
Yeah.
I have another wrinkle to put on this one as well, is if you have a resin system that has already been submitted and approved by a customer, and you have, 7 years of Florida durability on the fence, am I going to rip that binder system apart and submit something brand new and start all over again? Or am I going to find a different solution that might include an additive that gives me, most of what I need?
Yeah.
And so I think the formulator and their resin system has a certain relationship to a body of knowledge that's already been documented from a weathering sense.
Yeah.
That becomes pretty important and makes us maybe a little risk adverse to kind of dropping and replacing resin systems so quickly.
Yeah. Any questions from the audience regarding the last 50 years in formulation? Let's go to the next 50 years, or maybe the next 10 years. So this is the list the committee put together in terms of what we think is going to be facing us in the next 10, 15, 20 years. Energy consumption, supply chain and raw material costs, stringent environmental regulations, removing materials of concern, mixed metals corrosion, that is, if I've got an aluminum fender next to a steel door, and there's, what's the chances of corrosion because of that? Customization of colors, we talked a lot about that in the keynote. cost versus performance for the mass market, and application complexity and labor shortages. More robots, more AI. And then maybe some of the responses to that in terms of innovation from us would be systems that cure at lower temperatures, structural colors, self-healing and functional nanocoatings, autonomous vehicle compatible coatings, overspray-free coatings, that is high transfer efficiency, recyclable and reusable coatings, smart coatings, smart active coatings, paint replacement technologies, and AI-driven R&D. I think it's interesting, before you guys kind of jump into that, this morning, I think 3 or 4 or 5 talks were addressing some of those things that we thought, and maybe that's where we got the idea. We just looked at the titles for the talks. Anyway, what are you guys working on now?
So, I mean, there's a lot of things going on, obviously, that address all the things you just mentioned. I want to bring up one because it kind of relates back to what we were just talking about. So, if you've been to Focus the last few years, you would have seen a lot of talks on overspray-free technology. There's a few different applicators, different approaches to that. And one thing that Mike taught me several years ago, because Mike's a good rheologist, is that, you know, for these overspray-free technologies, we in principle will have really, really good control over film build. That's going to be important. And so if you have really good control over film build, your rheology is different, but it no longer has to deal with, oh, in this part of the car I've got 60 microns of clear coat, and this part of the car I've got 40. And so you're solving a different problem then that allows you to use different tools or use them in different ways. And I think that's a good example of how our specifications will need to change, how it changes the formulation box because of a new process that was invented.
Yeah. So overspray-free coatings, we kind of think of them at the same time we think of two-tones. And I think the original name for overspray-free was digital application or something like that. And I noticed a lot of executives were like, that's nice, you're going to cut my cost for two-tones. And then somebody called it overspray-free, and now they want to paint the whole car that way. Is that feasible? How long do you think, 50 years from now, we'll be not spraying, but actually digital application for the whole car?
Take that one.
I mean, 50 years from now, I don't know. I mean, clearly there's a need in the industry for all the reasons. There's a big money carrot out there for being able to significantly improve transfer efficiency and probably also do some digitization. When the technology, both from a hardware and a can of paint perspective, will be there to do that, I don't know, but clearly we can all see the advantage of that.
Yeah.
I mean, I think productivity needs to increase dramatically. Again, I think that'll happen. I don't know how quickly.
No, if you're comparing a digital print application versus running the same vehicle through your paint shop twice with masking and doing a two-tone, then there's a great opportunity for even slower productivity digital printing devices to make up for that two-pass operation. And so that makes a lot of sense.
Right.
To go to a whole vehicle would be a really tough price to pay from a productivity point of view.
Yeah.
Acknowledge that. But I think there's lots of opportunities for advanced applicators. I know the people from FANUC would be happy to hear that there's a lot of opportunities for improvements as we go forward.
Right.
Yeah, I mean, we've been looking at it for quite a few years now and continue to look at it. And part of it is we need designs buy-in. There's the limitations of the technology. We still need some trim pieces maybe to cover start-stop points, and you know that's cost to the vehicle. So it's really a look at the overall enterprise cost on what the best solution is. But yeah, I think it's something that we haven't given up on. We're still actively researching and investigating and how to best use the technology. But yeah, I think the full vehicles, 50 years. Marco says yes, 50 years.
So looking at our list, at the top is low temperature curing. I think we continue down that path. Where are we at now in terms of low temperature, and where are we going to be at, do you think? And even is it possible to avoid painting the plastic parts separately, but mounting them prior to the paint, and because you can apply and bake at a low enough temperature for that.
Yeah, I don't know that we can tell what's going to be the winning technologies going forward at this point. You know, I hesitate to even predict out 5 or 10 years. But clearly there's lots of experimentation. If you look at I don't know if there's anybody from Tesla here today, but if you look at the Tesla Robotaxi, right, those panels are not painted at all. They are injection molded with a polyurethane clear coat applied in the mold after they're made. So there's no decoration done by Tesla for that vehicle. Those panels are mounted. We get asked those questions all the time. Why do we need to build a new paint shop here? Well, why can't we do something different? And you probably get asked those questions too.
Yep.
Painting is expensive, and so yeah, there's a lot of energy around doing it differently.
Low temperature curing, can reduce the carbon footprint. If you do the analysis, you definitely save a lot more carbon if you eliminate the oven, not turn it down. But you turn on the oven, you're going to save, and it'll be measurable. And we've had some of those discussions today. Across the globe, there's a couple of locations that I'm aware of that are really talking about painting, fascia and parts online with the body. I tend to think that'll grow slowly, because I just think back, we could have done that any time over the last 30 or 40 years, and it really hasn't caught on. Maybe some things are changing now. So we'll see. We'll see how that evolves. But certainly reducing temperature can save on carbon footprint, and I think some customers are going to try to capture that.
Yeah, I mean, for GM, we usually call their bluff and say, okay, and then they go, well, who's going to build the fascia? Because we right now, all of those painted parts are sent to the plant assembled, right? So if we brought everything in the house, that painting is just a small portion of that. There's a lot more operations that have to be considered when you start bringing those plastic parts and painting them at a low temp in house.
Yeah, there are a few examples, but you pay the price on productivity and defects, and we have some experience with part bucks going sequentially right after body parts and things like that. There are a few examples out there, but they always suffer on either productivity or defects, and so these are big challenges. Mark said that we have a lot of smart people in the room, but I look at this list of challenges in front of us, and I'm happy that my competitors have to face the same list that we face. I mean, we're all facing the same physics problems in the end, and these smart people are supporting, good salaries and high technology, and a lot of that is our job security as an industry. So I think as much as we tend to want to be gloom and doom about these challenges in front of us, they are also the challenges that support what we do for a living.
That's right.
Yeah. I mean, I think one of the big challenges that's on the list there is I think I'm sure GM is, I know Ford has, I think all the OEMs, and I think the paint companies have all signed up to these carbon neutrality goals by some date, usually 2050. And if you look what it takes to get there, sometimes the technology is feasible, but it's very expensive, either on a capital basis or a variable cost basis, right? And it gets, you've got senior management saying we want to be carbon neutral, but almost none of the ways to get there are free, and sometimes they're very expensive. And there's going to be a reckoning at some point around, are we going to do this and spend the money we need to do it, or are we going to push things off to the future? And there's a lot of really interesting things that can be worked on technically, but I think it's kind of up in the air how that's all going to play out over the next, 24 years.
And I think related to that, Mark, and what we will discuss, internally and with customers is, what is a manufacturer compelled to do? And everybody's made statements and PPG's made statements, but in the end, what is compelled by regulation, versus the costs. And if we can find things that actually, improve productivity and reduce costs and carbon footprint, I think those things will certainly be implemented. But, otherwise it becomes a technical challenge to really figure out what the future is going to look like.
Yeah, I think recycle and components and green technology fits in that same category. We've been talking about that for years. And, every time it comes with a price.
Yep.
And if the customer is not willing to pay that price, then it becomes a moot discussion point pretty
Yeah.
quick.
Would the ability to recycle coatings improve that carbon footprint? Or, you know what I'm saying, because that sounds really difficult, and you're saying, is it really worth doing? And would it add much to your CO2 reduction?
I think you'd need people with a very kind of special backgrounds who can do the computations to justify those kind
I
of
see.
costs and improvements. But I think there are a lot of people who think really hard about that
Yeah.
in regulatory circles.
I mean, because if you, just the nature of the product, that's so much of our carbon footprint, right?
Yeah,
That part of it is so minute. It's more how do you get rid of the gas vehicles that we all love, right? So that's the biggest if you look at how we're contributing to the carbon problem, that's the biggest deal. And then if you look at the manufacturing side, it is the paint shop. So then that's the next question, is how do we do that? And on Marcel's presentation earlier, I don't know if we highlighted maybe the energy savings as much, but that's a huge portion when you're not humidifying and you're not doing all of that treatment to the air and you're not pushing that much air. That's a big win as far as the energy of the shop. And then then you jump to ovens and what do we want to do with ovens? So I know some OEMs are trying electric ovens, mostly coming from Europe that see those requirements. So we're all kind of watching and seeing how that goes.
Yeah.
But it's it's capital intensive.
And it's variable cost. I mean, electricity is very expensive compared to natural gas today. What the future holds in terms of the price of gas versus how we generate and renewables is TBD, and kind of is a political question at some level. But those are the exact same questions, exact same things Sarah mentions.
Interesting.
And it varies dramatically globally. So the
Yes.
solution in one region may
Yes.
be different than the solution in another
Absolutely.
region. So, it drives complexity, but it's the current state.
Can you talk a little bit more about that? You all work for global companies, but the regions are different. You just mentioned we're watching Europe because they do more of the electric ovens. In your work, how much region to region, taking it, like you do it first, and if it works here, we'll use it here. Does those kind of discussions go on, and particularly on the technical level?
I would say yes, because I think, you look at HAPS regulations, for example, which are being pushed a little harder in Europe right now than in the United States. I think once a success has been proven out in one region, other regions are very quick to replicate those gains. And so it's really a question of which region will introduce or force the introduction of a certain technology when, because I think in the end, everybody wants a cleaner environment. Everybody wants, better productivity, lower costs, more glamorous colors. And so it's really just a question of which region is going to get the introduction of a new technology.
Yeah, at GM, we have global tech teams where all of our technical people in the different areas will meet regularly to talk through what we're doing here in North America, what they're doing over in Korea and South America. But where I've actually been surprised in a lot of my dealings is actually, this is a plea to all my suppliers, is some of where we'll see stuff happening in Europe, maybe with a certain supplier, and ask about, well, why can we do that in America? And then it's they don't really know what's going on in their own kind of. I feel like there's some gaps in our supplier base where their different regions are more siloed than even our OEMs.
Interesting. And we've gotten some topics and questions from the audience, which is great. And of course, as we talked about getting ready for this, AI is the first question that pops up. In particular, artificial intelligence, have paint suppliers use AI to help with formulation or help reduce the work or help reduce the workloads? So can you comment on how much you're using AI already and what's it going to do in the future?
Well, I would say, at PPG, we definitely have a strong focus on figuring out the value of AI for the future, I would say it that way. I think it will make us better. I think it will make us more efficient. I think it will help dramatically in the front end of a project. I don't think it's going to eliminate jobs for young people that worry about that, at least in the paint formulating business. Part of the reason is the discussion from this morning, specifications. That today essentially every customer has different specifications, and to get a set of data in a structured way to solve a very specific chip test on a very specific color on a very specific metal, I just don't see that coming very quickly. But I think the general, where it makes us better and more efficient, will be the again, just chip as the example, the fundamentals of how to make, pass a chip test or a durability test. But you're still going to have to, develop the colors, do the panel work against the very specific tests. And, maybe that evolves in the future. But today we're not that close. The other thing we talk a lot about, which I think is pretty common in other industries as well as ours and at PPG, that we don't have structured data. We just don't have it. And it makes it very hard to analyze. So, we're working very hard to really do better at how we collect data universally so that we can really grow big data sets that can be analyzed very effectively.
It's not just PPG. When I joined DuPont in 1987, they handed me a hardbound laboratory
Absolutely.
notebook, and I had to
Wasn't
get
that long ago.
every page had to get witnessed by my colleague down the hall or something
Yes.
like that, so that it could get microfilmed and locked up someplace. And
Yeah.
so when you think back at the transition from those days to where we are today, I think putting some structure to how we define experimental objectives and how we make conclusions and draw data sets is really a big first step that has to happen before any AI bot can go harvesting the next
Yeah.
greatest formulations. So I don't think young formulators have such a big concern, but I think the way that we take our data and we draw conclusions about the fundamental physics that's going on behind the paint formulations is really something that's very critical to kind of moving ourselves towards where AI can do something with the information that we hold.
Yeah, we've had conversations. Our senior leadership really does not like having to wait on Florida panels for results. And if there's a better way to get an actual field performance, yeah, please let me know. But so it's like, well, why can't we AI that? Well, you need data, right?
Yeah.
You need lots of data, and we really don't have that much. Even for how long we've been doing it, we really don't have that much data. And if you go too far back, those pigments probably aren't even relevant anymore. If you have 40 panels out and 2 of them fail, okay, well but the time you accumulate enough data, it's just it's just not feasible, right? So it's quicker for a smart engineer to look at that and say, we probably have a problem with our oranges. We should go take a closer look at oranges as opposed to trying to develop AI to do that, which is just not necessary. So
Right.
the data question is still very, very valid in this space.
Yeah, I just think we're in such early days, right? We think about
Yeah.
how it's kind of exploded, but I think I have a hard time at least imagining what the state of the art in the AI will be 5 years from now. And maybe I can't even imagine it because I'm not an AI person. But I know there's other applications, right? So I think all the big OEMs and I'm sure the paint companies have people that they pay to do simulation work. And often those simulations are very computationally expensive. Will that be a role for AI to dramatically streamline and reduce the cost of what maybe are expensive simulations now?
Yeah.
Maybe, but I think there's, it's not just formulation, it's not just, properties,
Yeah.
it's some process stuff too that I think could be affected.
I can say it's really good at writing bios for conferences.
Or new headshots.
So, Jack, I'm curious that, Mike kind of said, like, I'm not going to go out to ChatGPT and ask it for a waterborne base coat for a particular model or something like that, but rather he was suggesting each company is going to create its AI from the knowledge that's already there. And is that what you guys are working on? You said you were kind of developing things like grabbing the knowledge internal and then training a computer
Well,
system?
it's both. I mean, we have paper notebooks like Axalta does. We're electronic now, but the data's not structured that well. So to me, it's really two-pronged. One is with what we have and with the data analytics that's available, what can we accomplish? But then moving forward, just start to do things differently so that the data is well structured. And I think we can build huge data sets quickly because we're a large organization. Like, we can have pretty big data quickly, and if it's structured, sort of back to Mark's point, we'll see what we have in 5 years, because we're going to have a lot of data that analytics folks are going to be excited about analyzing.
Yeah, I think for GM, the AI space is really happening more in the plant and the data that we get from paint processing. There's a ton of data that we collect that we just don't do anything with. So it's getting it into the right format, getting it into Databricks, and then seeing if we can, make the process more efficient, help our process engineers to make better decisions and run the shops better.
Yeah, I'll agree. That's the exact same thing, right? We generate tons of data in our shops, and some of it gets looked at, and it doesn't get looked at in a way that's structured and is actionable. That's something. So, yeah, taking all that data that we produce and getting it, turning the crank on it via AI could be a promising area.
Yeah. So we're almost out of time. And from the audience, I think one of the best questions, what are you most excited to see in the future of automotive paint? You go to work every day, you work on this, you work on that, and you say, boy, that gets me really excited. Anything like that in your works?
I mean, I would love to see, the industry at a point, some number of years in the future, where the paint shop was no longer the big environmental footprint that it is today, and that we can do things much more efficiently while still giving customers, great appearance, great long-term durability, great corrosion resistance. But if we could do that with a smaller environmental footprint, I mean, that'd be a real win for the industry, and I think, just for the world.
Mm-hmm.
Yeah, I mean, for GM, the next few shops that we have launching, there's a lot of automation, new automation that we've put into these shops that, as labor costs increase, we've been focusing on trying to do as much as we can with automation, and there's a lot there. So seeing those shops launch and seeing, because, the less people, the better the quality we get out of the shop as well. So seeing those start up, and then, even the next one after that, the expansion of high TE, going the 3 wet to 4 wet kind of discussion, just getting all of that into a really highly efficient, low energy, low people kind of space. So it's exciting to see what that shop brings us as far as quality.
Yeah, I think from a paint supplier point of view, I think we take a lot of pride in developing paints that enable the kinds of changes that Mark and Sarah are talking about. Is that, you won't get that great productivity or improvement, whether it's, by process advances, or you won't get the environmental footprint reduction without changes in the formulation. And then there's a layer of physics and chemistry below that, which is really the responsibility of paint suppliers to come up with. And so I think we will take great pride in introducing the products that will enable those kind of changes.
Yeah, I would just really echo the same thing. I think it's an exciting time, for the paint industry, because, cars are going to be produced differently. And that's going to require different decoration processes. To me, the good news is consumers still like customization and decoration on their cars. And that's true in other industries as well. So, foundationally, they still need to decorate and protect. But it's going to be done differently, and maybe dramatically differently. And I think that's exciting to find the solutions to enable it.
Yeah, agreed.
Great. It's 2:00, which is the end of this session. Let's give these panelists a show of appreciation. So now we're entering into the longest break period of the day. We did not have dessert at lunch, but there's treats in the room where the posters are. If you haven't stopped and looked at the student posters, please do so because they're very interesting and we love to get that support. Thank you very much. Yeah. Great.